I wanted to ask you, what is your suggestion for young engineers, young builders that want to approach very, very hard industry, and want to build in it? And they know, they know there's all sorts of problems that have to do with friction, resistance, lack of talent. Their friends telling them, hey, I work at a tech startup and I make 150K a year. Why don't you just join us? Etc. Like all of this stuff, but they want to build stuff that other people find boring, and they want to explore how the traditional way of doing things can be changed and the status quo can be surpassed. What's your suggestion for them, really high level, that you would give to yourself,
Yeah.
back when you started out?
Yeah, I see. Well, the first thing I think is important is that what you want to do, you want to change the way stuff is built. If we put it that way, you're a young person, you're 24 years old, you're just out of a university, and you see there are so many things that needs to be addressed in this industry that we're in. That's great. Now, if you really want to change the industry, you have to make sure that you're part of changing that industry from the inside. So your first years that when you're working will not be any breakthrough, because you're going to be so busy understanding what's going on rather than being that breakthrough force during your first years. So just be very patient with yourself, because a breakthrough in the industry we're working in is not happening unless you are able to get, you have to be trusted by everyone. When you stand up and say, hey guys, we're doing it this way, you need to be sure that your people on the floor, your engineers, your financial people, and your warehouse people, all of them understand that what he's saying is actually making sense. We should be doing that.
How are you guys getting, young talent? And what do you think is the key for the future manufacturing companies that are working in construction, that are working to manufacture homes to attract talent? Is it the focus on software? Is it the focus on branding? Like, what is it that can actually work?
First of all, you can never do this without engineers. And there are a few engineers that are super important. You need a manufacturing engineer who understands flows and takt times and can measure and collect data and help you with improvements. Super important. And then you need the engineers that are feeding the product specification to that floor. You need people who can speak to robots. You need people who can set up a file so an automatic saw can function. Those are people that are as a very specialist knowledge. But if you walk into other industries, they are there. If you walk into someone who's making iPhones, I'm sure they have people who are specialists in all the machinery that's needed in that factory. And you need that here too. If you don't spend money and time there, it's not going to be a factory that functions for you.
What do you think and by the way, it sounds different, but it's of the same nature, which is the generational change, the way that we set manufacturing businesses. What do you think is a smart way, because you've looked at the economics of the factory and the financials of the factory, to finance and start working on a factory?
I can tell you already now that your factory is going to be not positive the first 2.5, 3 years, because that's the time it takes if you're doing it at scale to get yourself to a positive result here. So when you're talking to money representing funds and all of that, that's part of the equation. There's just no quick fix. And I'm saying this with all the care in the world, because some of the construction projects we're working in, they don't convert into something that's producible until after 18 to 24 months. And that might be short in certain areas.
Hey everyone, and welcome to BitBuilders, where we sit down with the greatest minds building and exploring robotics in construction and space. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology, and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
Hi, Helena. Welcome to BitBuilders.
Thank you. It's nice to be here, Gabriel.
I love that we got introduced through a common friend of ours that we really think highly of in the space of what we're going to talk about today, which I will not spoil for the audience because I'll let you say, who you are and then infer. But why don't you go ahead and introduce yourself to kick it off?
Yes, thank you. I will. My name is Helena Lidelow. I come from Sweden originally. So I have grown up in the modular industry in the Scandinavian countries. First doing some research for academia, and then working 12 years for the largest Scandinavian manufacturers of wood structure modules. And during that time, I was part of the team who stood up a new factory for Lindbacks big. And after having spent so much time learning all of that, I took that experience and joined Volumetric Building Companies. So I've been with VBC since January 2022, so 3 years now. And it's been an exciting journey to see how the contrast is stood up between different cultures and different people, different knowledge bases, and it's just been a very cool journey to be part of.
And I'll jump on the main topic with a question that has just occurred to me, which is, what's up with Scandinavian countries and modular building?
Yeah, it's a good question. So here's what we do really well. We are good at adopting technology that makes sense for us. So there are several examples that you can take a look at in the broader industry. We are the home of IKEA. We are the home of Volvo. We are the home of H&M. And all these companies have it's a common sense solution to an everyday problem. And they are set up in a logistically and financially pretty sound way. And this has transpired and moved also into construction. I come from an ecosystem where 90% of all my single family homes are made in a factory. So this is nothing special. I don't have a site-built industry for single family homes. My norm is that they are made in a factory. And even when my parents built their first home, I remember being with them and looking in the catalogs. This is how you get your home. And now, during the years, this has been transferred also to multifamily homes. So I have a very high penetration of prefabrication methods, being it modules or panels. It's around 50 to 60% that is done in a factory, regardless of material. So I have a high degree of prefabricated concrete slabs, precast different hybrid structures between steel and concrete, and then also wood timber. There is a vibrant mass timber industry. So the knowledge around specifying, making, and assembling prefabricated structures is high in the Scandinavian countries. I think the driving forces are two very traditional things. We're not very many people, so we don't have the luxury of having a lot of people that can be on site. It's very cold where we live, so it's not very pleasant to be on site either. And the workforce that we have has a high labor rate, so it doesn't really make sense to spend a lot of hours on site because we will outcompete ourselves in construction.
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
This is very interesting because I think it touches a lot of the reasons why, in general, zooming out, modular is an interesting alternative or an interesting complement to our way of building houses and building structures in general. And I think I want to do a little bit of a deep dive on that, but I want to try to understand, how did you get involved with construction? Like, how did the young, very, very young, out of school you say, hey, this is actually a cool place to start looking and, start building and studying?
Yeah.
What was the history that brought you here?
I'm born in a super small village, just close to the Norwegian border. We were 4,000 people, maybe. It's in the middle of the woods, so there wasn't much else to do than either walk in the woods or work with the woods, if you put it that way. But then I've been always drawn to physics, the natural sciences, and understanding how the world works. So it became very that's a natural path for me, being talented in those areas. And engineering was then the obvious way to go. So I did that. And then during the years, became a civil engineer with a structural engineering specialization. And then thought that school was so fun, so I decided to stay for another 5 years and get my PhD. And there was a time when I thought I was going to be a full-time academic professor in this area, and just entertained that, and pursued that, and built a network for it. And then was kind of offered to move or migrate into industry. So it's been a fascinating journey personally for me.
And so the main builder in Sweden that actually sets an example that's for the audience, right? So Lindbacks has been setting examples for the modular industry globally. There's another couple of very legendary builders in Japan that have, that do things extremely precisely. We'll get there. But I know for a fact that a lot of US people that are thinking or already designing a modular factory simply ask Lindbacks to do tours. And they go, they see what the operations look like, they talk to the management if they have the chance to, because this is the highest example of excellence in a market that is as close as it gets to the Western ecosystem than for the US, right? So it's a really good example to draw from. So how was for you to work in Lindbacks? How's that company? And I know you have very fascinating insights with the comparison with the US, but let's start from there, right? So what's special about that company? How old is it? What's their legacy? What was your approach to helping them, build out even further this empire?
Yes, good question. Lindbacks was born as a company in 1924, so they recently celebrated 100 years. And I think that's the first key to be successful in modular, is to have a very long-term approach. You are investing so much in a factory and a factory setup. So you have to make sure that you sustain that investment by feeding it the right projects and making sure the cost levels are at the right level for your client base. That trick is something you cannot teach yourself or your organization in a matter of a year or two. It is a daunting task that requires you to have a lot of market knowledge combined with technical knowledge. So I think that balance between understanding what's technologically sound and wise, cost-wise, smart to do, in conjunction with what does the market really want, is what shaped what Lindbacks became over the years. So there are a few goalposts or boundaries that were never passed. They always made multifamily, period. There was no single family, no extra type of asset class like schools or public works. It was always multifamily. And that helps the organization to understand what is the product we're making. There was a high degree of standardization in the factories because they had one when I started and they had two when I left, and a third one in a workshop mode. So it was clear boundaries for the building system communicated. You cannot build wider than a certain amount of meters, 4.15. You cannot go longer than 9.60 meters. It can never be higher than 3.0. And those items were communicated very clearly back to architecture. And it was a hard no. There was no negotiation if you were to break those rules because it was not a negotiation. I think those types of things are indicative of also a population, because this was Sweden. And I shared with you the examples of other companies that has been successful in Sweden. One of the other keys there is that you have a population and a culture that's pretty accepting of a good medium standard. And there are very few clients who will tell you, I want what I want, and that's the way I want it. That is not how you negotiate. You're doing it for the common good. And I feel that is something that is different in terms of how I experience other areas of the world. I also know that we have an inclination to like functional design, which means that the Scandinavian countries, if you've seen the design aesthetics we have, clean cut, there is not a lot of junctions and nooks and crannies. It's very actually manufacturing friendly when you start to look at it from a production viewpoint. And that has also helped that you're having a standardization of the aesthetic itself. It's kind of supporting the idea of industrialization.
I think it's clear when you look at the design in those countries. So I've been to Sweden a few times and to Norway a few times. I've never been to Finland, but in any Scandinavian country that I go to, and actually I've lived in the Netherlands, in a reconstructed Netherlands, right, in Rotterdam for a while, and there you can see some signs of it. There's fully, focus is fully on being functional, and the aesthetic derives from the functionality. It's like, it's cool because it's functional. And it happens like, it's very random, but 2 days ago, I went to the Dessau, close to Berlin, where the Bauhaus
yes.
Headquarters was, and still is. And it's incredible that I actually found out that they were the first ones to think about, in the Weimar Republic, so between the two wars, they were the first ones to think about, hey, how do we make houses for the masses? They're very, very functional, and they can be streamlined with everything that's inside of them. They weren't thinking about modular specifically, but everything that's inside of them will make it, manufacturable in series, in bulk. That made me think they were actually the precursor of IKEA in that sense. So that was the 1930s, and I think it also coincides with Lindbacks' foundation. So, jump that to today. You went to work for BBC, who's one of the, I wouldn't say the new kid on the block, but at least the new big kid on the block. Can you tell us a bit more about what Volumetric Building Companies does? Maybe sprinkle in a bit of what does Katera have to do with this? And yeah, just, give us an overview.
Yes.
Why did you jump ship?
Why did this happen? My entire year spent in the Swedish industry was focused on DFMA. So design for manufacturing and assembly was all I did. I ran the design team and the R&D team during this period, which meant that designing things that were meant to be manufactured was what I was good at. And then, as always, there is a personal relation. So I knew the CEO of VBC, Lindbacks. We met on several different occasions around the globe. And he called me one day and said, we're going to acquire what's left of Katerra in California. And I knew what Katerra in California was doing because it's actually full of machinery that I already have a relation to. There's a lot of Weinmann and Randick and all types of robots and stuff that was hanging around in that factory in Tracy. So we hung up and I needed to give that some thought, but then that was not a random phone call. This was an open door. So I called back and said, well, maybe this is the time when we work together then. So it took off from there. And the idea was to come and support with setting up operations in the former Katerra headquarters in Tracy, California. So I transitioned out and got myself a visa that enabled me to work and got into the Katerra shop floor. And this was after their bankruptcy, and they picked up what's left and so forth. I walked onto that floor and realized that this is more equipment than anyone would need, and started to sort out what can we use and what is non-useful here, because we were not doing what Katerra was doing. Katerra was doing panelized building components. Their entire idea seems to be revolving around being able to provide a full building, but with parts that they made, panels, kits, windows, and all of that stuff. It was a beautiful idea, and the operations were really nicely set up. But it was way too expensive for what we were doing. And also, it was much more than we needed. So we started restructuring that shop floor. And we had some external help to do that and made sure that it's now a flow that can produce modules then. With the timber frame structure, we imported some machinery from different types of suppliers that we already had in our back pocket, and help set up the factory.
That's the time for a framework alignment or something in the spectrum of, hey, give us a crash course on a few key elements, and let me help you out with where we start. I think what could be very interesting for the audience is understanding what is the difference between volumetric and panelized modular, which I think are the two biggest branches that we can, the most high level top down view that we can have of what modular can be. Then I think what a tact flow and, good measures for throughput are, both of these can be a good start. And then maybe you have other ways that you can explain to your completely working in a different industry cousin,
Yes.
type of person, what you do. So give us a crash course on this so that we can follow.
Yes, good. Volumetric modular versus panelized modular. This is one of the things where I see the difference from having worked in an industry where all these different methods blend, and where I'm still feeling that, especially in the US, there's a great need to actually categorize and identify and label, because you just need that for your own understanding. So volumetric modular, 3D volumetric elements are boxes. They have 3 dimensions, X, Y, and Z, and you make the entire box inside the factory. The size of the box is typically 4 by 3 by 8 maybe, in terms of meters. So it's 14 by 12 by 30, maybe, feet. And the whole idea is that you build the entire box. It's a load-carrying structure in itself, and you fit it out. So you fill it with the bathroom, the kitchen, you do all the paint and mud, and you do all the MEP works inside the factory. So when you come to site, 75% of your building structure is complete, and you assemble these modules on top of each other. And what you do on site is give the building a roof, give the building a facade, and you stand up the foundation. So kind of the envelope that you wrap around the modules is made on site, and the rest is inside the factory. So by doing that, you become a really large portion of the building project budget, because 75% of the value is created in the factory. So now that kind of changes the power balance for a general contractor who works on site, because you are, as a sub or a colleague to that GC, now providing the majority of the worth of the building. If you move to panelized, in my head, panelized is a subset of modular, because you need to make the panels first. That's how I was brought up until I learned how it's made in the US, which that's not required. You do the panels right there on the floor. But panelized is flat. So it's a two-dimensional element. It's an XY. So you have a length and a height, and that's it. It's a wall, it's a floor, it's a ceiling. It can be a plumbing stack maybe, but mostly it is the building components that are structural that you're addressing as a panel. And you can make them as well in the factory and finish them off. Katerra, as an example, was doing open panels, which means it's the load-bearing structure and the outer sheet, the OSB sheet that carries your shear. That is the product that you're delivering to site. It can have some penetrations and it can have some plumbing or electrical in it, but it's not necessary for everyone. I, who come from the Nordic countries again, we're used to making closed panels, which means that the panels not only have structure and sheathing, they also have insulation, vapor barrier, the electrical and the outlets, it's in there. I would install the windows, and I would have a special technique then to join them on site. And the difference here, why I'm doing it one way or another, I learned is a lot about the quality control. So the quality control inspections that I need to have in the US context is most often prohibitive to close the panel in the factory unless I'm set up to do that with the QC on site with an approved process. If I'm not, I'm leaving the QC to whatever happens on site, and then I need to leave the panel open. So it's an easier business setup to have inspection on site. The Nordic countries and Europe as a whole doesn't have this type of QC structure with a third party that has to be on site and give their opinion. We have a QC system, yes, but it's not hindering the method in the same way that I can feel it can do in the US. So that's the summary of 3D and 2D, and I forgot the rest of the questions. You will have to help me.
No, I mean, there's already plenty. I did not know that the QC structure dictates what can be done and what cannot be done, or actually what's more cost efficient to do. Because I guess you could, join the panels and then find a way to kind of like open them up.
Well, you can.
So give a view of that can basically lead to QC and QA, and then once you're complied, you close them up, you're done. But that requires additional steps, which bear additional cost. So this is very interesting. So thank you for that definition. What I want to know is now, we are outside the factory. What happens inside the factory? So duct flow and, what's the throughput that we should expect from a factory like this, right? So what should I think about? Should I think about homes? Should I think about square feet? Should I think about units that you described as, containerized boxes? So what are the metrics that basically you were hired to make work?
Yes. Okay. So the first thing when you set up a factory, let's assume you are a person and you have a bunch of money hanging around, and it would be fun to start a factory. You have to decide on scale. This is the first thing you do. Are you standing up a factory to support a business that's selling, let's say, 100 homes a year? 100 homes a year is one every day. One every other day is what I'm trying to say. I'm sorry. And you're kind of, it's not much when you look at throughput. This can be done with manual methods. No, you don't have to invest in any machinery. You need a shed, more or less, and people, and a good instruction, and some tools. And then that's fine. And I have no disrespect for people who do that. It's a very viable business model. It has pretty low risk because the project you are now approaching doesn't give you as much spend, or you don't have to have a big cash flow to support it, and you have control. It's a small amount of workers. So it's a good business model to live on. And I can see many of them have existing, both in the US and in the EU. Smaller, basically family-owned operations are making homes. Great. Then there are others who have aspirations on scale and want to, I don't know how many times I've heard this, but they want to disrupt construction. It won't happen. So let's just release that thought from anything. There is no disruption in this industry. We will make improvements, but disruption, not so much. When you're looking at scale, and now we're talking thousands, you need to be thinking differently in your setup. So if you are to make, at the height when I worked in Lindbacks, we made 2,300 modules, and that's 3D volumetric complete elements a year. We were clocking 12 to 14 mods a day per shift. Now you're on a scale where you're moving the module between two stations every 45 minutes or so. You can't afford in that system to have too much manual work because it's too costly. And if you're in a setting like we were in a Swedish setting where labor rates are equal to or higher than what you would have in the US, you just simply can't afford the workforce to do it for you. Now, there is one thing that people forget as the prospective fabricators. This is an extremely hungry animal you are just creating now. It needs pipeline and backlog. If you're not able to sustain this, don't do it. This is very, very difficult to sustain because you need a lot of financial backing to make sure that pipeline happens. And is stood up and is vetted in a way that the factory actually can run. If you're not up for it and don't have the organization, this will kill your operation financially because you are not able to sustain enough scale to make that factory fly. Now, what are we looking at inside the factory then? If we are past all those hurdles and are agreeing that, yep, we will do this, this is our future. This is manufacturing flow. In a manufacturing flow, you can choose to have one or several parallel lines that you're feeding out from the factory. The most common way of organizing any manufacturing flow today is having a main assembly flow that you feed with sub-assemblies. It's a fishbowl. And that is the way I've been operating and setting up factories. There are several other methods too, but the large scale operations I'm discussing now seem to be fitting for the fishbone thought. And what's the fishbone then? if you look at how you build a 3D volumetric piece now, you would start with the floor, you would add the walls, you will add the ceiling, and in between those steps, you will also add the major pieces of the MEP systems into the box. So it becomes a 3D volumetric module, and then you finish it off. Those are the basic steps. Now, the speed of this system is highly dependent on how many work tasks you have to do on the assembly line. Because if you only have 45 minutes to complete your task at one station, you have a very limited methods on how to decrease that time. Either you move that work offline, which is into a sub-assembly flow, meaning into the fishbone, or you elongate your line. So you extend your line to have much more stations, because then you get more time per each module to complete it. Both are possible. It all has to do with the footprint you're working on in the factory. So when you set a flow up, manufacturing engineering and layout work is really essential for what is the intended output you're going to get from this operation. And there are people in the world who are good at this. They can walk into a factory and tell you, well, I don't think you should have this work tasks at this station, because look here, you always have a bottleneck right here. And it'll take them 15 minutes to realize that, walking on the floor. So that's why I say think differently, because this is not construction any longer. This is now manufacturing. And you probably then also understand how important design is in this instance, because if you have a design that requires a lot of work, you will slow the line down, and everything you get is calls from the floor saying, I can't build this, my hand doesn't fit, it takes too long time with these screws, give me something else. Those was the feedback I was getting constantly, 12 years in my life.
First of all, I can imagine how stressful and intense it may be, because I think the base of the manufacturing and the weight, the physical weight of the output, they literally multiply, creating an index of complexity here and creating a high bar for design tolerance. So if you're wrong by a few minutes, you're basically delaying an entire structure to be delivered. And what you're doing is basically you're downstream, you're not putting less boxes of small products that you're manufacturing inside a truckload. You're actually not delivering an entire home. You're delaying a construction project that has already timelines on site to be assembled, reviewed, etc. So that hurts your pipeline, that hurts the track record. And so the input that you said that it's very important that you'd have to feed, and that's the primary consideration that you should have, that gets hurt too, because your reputation gets scratched. And so I can imagine how surgical, yet having surgery on elephant, that's kind of like the idea, right? So impact is enormous. The types of things that you have to do to change the way that the floor works are very tiny. So I have a bunch of questions, but I think what I want to start with is, what is a good way to evaluate a factory? My way, the way that I've been taught in this year of full immersion and in this industry, has been very rough throughput, real throughput, not like projections, throughput of square feet or square meters of homes built on, divided by the size of the factory. So basically, how much does a square meter of factory yield in terms of square meters of homes? Does that make sense? Are there other ways that make more sense and have different angles that we're looking at things? How should I think of evaluation of metrics?
Yeah, that's a super fair question. The measure you're addressing is a measure on how efficient are you to use the premises you have, which is one way of looking at it, of course. We used to use another measurement because it liaised better with productivity. So when I visit a factory, I ask two questions. First, I ask what is the throughput, to your point, and the throughput can then be counted. We counted modules per day, but you can also count square meters per day or square lengths, linear feet if you're in panels per day, or per hour, whatever that is. It's going to give you what is the throughput of the factory. I would walk to the end of the line and check that they're actually complete when they're leaving. So it's not a throughput where you're putting through 50% completion and you have to do a lot of extra work on site. That's another piece because you want to use your factory to the fullest. And the second question I would ask is, how many people do you have on your shop floor that are actually working? Because with the throughput and the number of people, I can now construct a measure, which is man hours per module or man hours per square meter. And that tells me how much work effort went into this. And that, for me, that's a token of efficiency. I've amused myself with collecting this measure in different types of operations I've visited. And there are operations that produce 3D volumetric in the US, who would be 400, 600 man hours per module. And there are operations in the EU that would clock in at 110 man hours per module. So you can see that there is a difference in how you think about the resources you're putting in. And why is this important then? The number of man hours might not be as important if the man hours are cheap. That is my whole thing here. But if you have very expensive man hours, those man hours are very, very, very directly coupled to your P&L. So you have to have whatever measure you're using, you have to make sure that it makes sense. So you run your operations with a KPI that actually drives the right behavior. So that's something that is important in all manufacturing, and they do the same thing in automotive. So if you for fun visit the Ford factory, it's close in Denver, I think it's close to. No, not Denver, Detroit. Sorry, throwing people under the bus here. So they, when you go there and you look at the flow, first of all, you have a really good view because you're on the second level. And then you can see the fishbone flow. You can see the material supply and how it all fits together. Their takt time is between 1 and 2 minutes per car leaving the line. And we're discussing how hard it can be to get under an hour. I think we have a lot to learn from other industries. I have full respect for the fact that we, in the modular or panelized industries, have larger components and they're more difficult to move and so forth. But an F-150 isn't small either. And it has a lot of components and it needs a BOM and it needs to be defined and so forth. So if we are really to succeed here, it will take a lot of dedication to that idea that you have to define your product, you have to stick to it, you can't change your mind every other second. And if you are in that business where you change your mind every other second, just don't build a factory.
Yeah, I guess the ceiling is given by also, the asymptote of how close can we get from the modular construction perspective to the automotive manufacturing perspective is given by simply, if I were a very, very mean chief technical officer of BBC, what I would say is, where we want to get is, the tax flow that Ford has multiplied by the differential between how much an F-150 costs and one of our houses costs.
Yeah.
So if one of our houses is sold for 100K and an F-150 costs 50, we're only allowed a 2x, worse takt time or slower takt time than they do, which is insane.
Which is insane. I agree with that.
It's completely insane. So I want to talk about the future, because I think now the audience would have, and me, by the way, more solid understanding of where we're going and what we're doing. Sorry, where we went and where we've gone so far. But I want to try to understand where we're going. So where the future is taking us with modular. I think BPC is at the forefront of a lot of this innovation just because of the scale that you mentioned. So BPC has reached a scale where innovation can actually be put to test with the production speed. There's a lot of companies that are building new systems, new factories that are trying out new types of designs for their own factory, for their own building systems, etc. And some of these still have to bear the test of time, right? And bear the test of throughput and literally just the stress of the pipeline flowing through those systems. So we've had Vikas from Reframe Systems here that is in the earliest stages, setting up a factory that is doing, I think, an amazing job in understanding how can matrix manufacturing, as opposed to the assembly line type of design that you've described, how can that be an unlock for higher productivity? And then he has to put to the test of generating $1 billion revenue. So I want to try to understand, where do you think production scale modular manufacturing can go? What do you think are going to be the tools that will make a lot of sense? By the way, the answer is probably software, but why and what? And yeah, what do you think is going to be implemented? Where are you going to implement next few years for BBC to keep yourself at the forefront?
Yes. I think one of the things that I also meet when I discuss with different types of experts in this field, I have the viewpoint that there is a place for many different technologies where we construct our world. I've never been a proponent of saying we should have it one single method, because I know that is not the answer. The way I've been working with automation at scale is only fitting if you have a market segment that supports that. If you're doing something else, you need to be looking at a different method internally. I like the way he laid that out in his podcast around using already existing robotics to build a flexible manufacturing flow that was adaptable but yet predictable. I think that was perfect for the business model that project and his company is running at. So super, super interesting. Where are we going with all of this then? The Industry 4.0 development, where you have all the machines kind of connected to a central brain and feeding back to whoever is running the factory, is going to be the infrastructure that we're working on. I think the piece that is the challenge is that many of the larger investments in factories at scale in construction also becomes prohibitive over time when you're changing your technology, or there are new trends for how your product needs to be built. I think addressing that will be very important. And the only piece where I really see this being able to be addressed in an intelligent and manageable manner is to do it with some type of AI or software setup that gives you the ability to evaluate options very quickly and tell you from the factory floor, what can you do if you have these circumstances? And this is, I say this also with the greatest respect for what has been and what is to come. This industry, when I'm retiring, this industry will be different. There will not be as many construction workers, but also not as many engineers and so forth, because we are in a decline. The this industry is not attracting enough talent, and there is not enough to build what we need to have in front of us. So we as an industry would do very, very well to make sure that we're actually teaching one of those AI engines to know everything that we do right now, because there will not be enough people to carry the legacy in the future. And I know I've been fortunate enough, or I'm old enough, I should say, to have worked with some of the people who were part of setting up the first factories that were ever built in the Nordic landscape, that were factories to talk of, and understanding how deeply they had to understand the manufacturing system they were working on to be able to complete their projects, and their technical challenges was very humbling. How you're past the point when you're trying to work within your parameters, and instead you look at your parameters and say, what if I do this instead? What if I produce the roof with another factory and they give that to me? Well, then I can produce what the client wanted me to. So now you're starting, it's a new level of how you operate and interoperate with others. I think one of the examples I would like to mention here is a thing that was very helpful when we were doing timber structure. I don't have the building asset classes, the building types that you have in the US code. So you have type 3, type 4, type 5. That doesn't happen in the European landscape. I'm allowed to build whatever as I want, as high as I want, as long as I fulfill all the functional requirements. So I've done 8 levels of timber frame, light frame, modular, just because I was able to also insert massive timber, CLT, as components inside the modules. And getting that type of cross-functional fertilization from different types of the industry, I think will be the future. It's hybrid construction we will need to master, to make sure that we know what that we can address everything that happens in the future.
It's daunting. I think one thing you said, it's really daunting, which is the way the places and workplaces and industries and problems that my generation is attracted to are radically different from where modular is right now. By the way, I think modular is the top of the range for construction. It might be that construction as a whole is even less attractive on average for college graduate or just someone that wants to throw their hands at a problem. And what I think it's going to be key is going to be keeping some of these learnings, as you said, and embody them and embed them in the knowledge and logic that will drive the manufacturing floor of the future, the design of the future, from the architecture stage to the structural engineering stage. We are seeing big mistakes being made from extremely talented people that did not get the experience beforehand, before starting. And I think I don't think Katera is a great example of this, but there's a few big financial cracks that will come from this. Because when you lose the tribal legacy knowledge of how things are done, you most likely are trying to reinvent the wheel, and you'll redo the mistakes that you're doing before. With the leverage of technology, the downside of that mistake, and the leverage of money too, the leverage of debt, the downside of that mistake will actually be greater. So I want to try to understand with you, how are you guys getting, young talent? And what do you think is the key for the future manufacturing companies that are working in construction, that are working to manufacture homes, to attract talent? Is it the focus on software? Is it the focus on branding? Like, what is it that can actually work? However minuscule and trivial it can be, I want to try to understand, because that will be my my advice to founders, likely that you're teaching me here on how to get good talent in a boring industry, which, by the way, I don't think is boring at all. But it might be the perception of people that are not looking at it.
I'm bitten by the bug, so I don't think it's boring either. But there are a few things that shift when you're doing moving construction, and that the larger pieces of a building structure into being made into a factory. You move that under a roof, and you start organizing yourself in repetition, right? A few things happen that changes the roles of people. First of all, you can never do this without engineers. And there are a few engineers that are super important. You need a manufacturing engineer who understands flows and takt times and can measure and collect data and help you with improvements. Super important. And then you need the engineers that are feeding the product specification to that floor. You need people who can speak to robots. You need people who can set up a file so an automatic saw can function. Those are people that are as a very specialist knowledge. But if you walk into other industries, they are there. If you walk into someone who's making iPhones, I'm sure they have people who are specialists in all the machinery that's needed in that factory. And you need that here too. If you don't spend money and time there, it's not going to be a factory that functions for you. There are a few other things that happen as well. Your material supply chain setup compared to being on site and when you're in the factory is now different again. You're working inside an ERP system. Maybe it's SAP, which is a heavy system but very competent. Maybe you're opening up to subcontract pieces of your materials out as kits to another supplier. You have to do warehouse control. You have to make sure that your goods is kept and stored in a proper manner. I'm describing all these changes because this is the key to how you can attract people into the business. When you're young and you're starting out as an engineer, there definitely will be people who will enjoy going to site. But there are also people who definitely do not want that because they grew up in front of a computer. They grew up being in a shielded environment, and then it might be more enticing to go into a factory setting and be working with some high-end definition of automation instead of going to site and doing quantity takeoffs on a sheet of paper. So there is a stark contrast here to what the industry can be if it is allowed to become an industry.
I guess the tools will make more efficient. So the tools that we'll adopt will make the floor more efficient, and the bottleneck will be: are there enough people to maintain, use, and upgrade those tools? And that's where I probably, maintaining a global throughput here is actually in and of itself already a decent result, because, on one side, you have a positive contribution of new tools and a negative contribution of the lack of talent. And there's another aspect of this that sidesteps a bit the talent question, which is, what do you think and by the way, it sounds different, but it's of the same nature, which is the generational change, the way that we set manufacturing businesses. What do you think is a smart way, because you've looked at the economics of the factory and the financials of the factory, to finance and start working on a factory? There's a lot of mixes, right? Some people are doing everything with venture money, which is expensive. You're selling equity. It's complicated, but doesn't, it's venture. So it needs nothing more than an idea on a piece of paper. On the other hand, you have hyper leveraged with debt operations that get financed. They're really risky. You put on the line your own asset if you're the owner. It's really complicated to get those work. And by the way, the macroeconomic environment, it's terrible for this right now. So today, there must be a way that makes sense here. What do you think it is? Because I know you're talking to startups and advising someone. So what's your take on how should we think of setting up that first Excel sheet that will actually make it into reality, hopefully?
Yes, this is a really good question because you can very well do exactly what you said. You can work with venture capital money, but they are impatient funds and they want results very quickly. And unfortunately, that model doesn't really play well with the needs of industrialized construction, where you need to be more long-term. I can tell you already now that your factory is going to be not positive the first 2.5, 3 years, because that's the time it takes if you're doing it at scale to get yourself to a positive result here. So when you're talking to money representing funds and all of that, that's part of the equation. There's just no quick fix. And I'm saying this with all the care in the world because some of the construction projects we're working in, they don't convert into something that's producible until after 18 to 24 months. And that might be short in certain areas. So you have to have a super full respect of what are you working in terms of a market surrounding. Now, there are a few tricks that you can use. If you're smaller and alone, I would suggest that you get yourself a parallel strategy. Make sure that you're making something that the market currently wants and pays for, that you can have, so you have revenue all the time. Because if you have revenue and can show, it doesn't have to be a super positive result, but a little, you have credit. And you can use that to build your real business, what you want to do with Modular, in the background. So you self-invest and you self-fund. This is a slow way of doing it, but it's pretty safe because you get to test out what works and what doesn't work in a very safe environment. You probably should team up with someone who's developing projects. Developers are often in need of capacity, and the long-term relationship for them is going to be important for them to succeed with their business, which is constructing projects and selling those projects as quickly and with profit as possible. So that is a good partnership to have. But don't do that as the first step, because they are also hungry. If they're a good developer, they will tell you, well, I need 200 flats in the first half year. Ugh. And you're just like, I don't even know where to start, So there's a lot of teaching and learning during this startup that's needed. I've seen a few examples when we flipped over, and I wasn't part of the company at the time, but when Lindbacks shifted from being an on-site contractor to an off-site modular manufacturer. It happened during a period of 2 years, and it was to shift the cost structure. Having on-site people was too expensive, and the panelized solution they had at the time was not bringing enough value to make the construction projects work. So they flipped that to 80-20 inside the factory and a much leaner crew on site. And that's been operating since 1994 then to do it in that manner. But it came with a knowledge of exactly how the market worked. What is the cost structure for me in a factory in a rural space compared to being on site in an urban setting? So knowledge about where you are and how to navigate is very important. I see some of the aspirational efforts being made. Oh, let's build a factory and it's going to be great. And you you focus so much on the factory that you forget a few basic things that will never go away in construction. This is a highly permitted and restricted, code regulated area you're in. If you even so much come in with a new material that no one has seen before, it's going to cause trouble for you. And it takes time to push through that system. So you can't build a factory that relies on a fancy solution that doesn't pass the permit process. It's just not going to go well for you because your product won't be accepted. So that's the first thing. The second thing is that you get so mesmerized by the idea of having a factory that you forget that the product actually has to go somewhere. And that somewhere is not, just anywhere. It's a piece of land that has services and has to be coordinated with what you're doing. There is a general contractor who has all types of opinions about what your product is going to look like and be calibrated towards whatever you're doing and so forth. So you have to work in the construction context and be doing that dualism. That's the key to success in modular construction. To be a manufacturer, but inside construction still.
So legacy techniques or legacy material. Starting out building a new way things that already were built or, with materials that were already used. And at the same time, financially being smart enough to generate revenue in a lower risk fashion while you set up your higher risk operation.
Mm-hmm.
These two are probably the biggest takeaway that I take from this.
Yes.
And then approaching the end of our conversation, which by the way, I would keep for another 2 hours because I'd love to spar with you on this. And I think it's one of the most information dense episodes that we've ever done. I wanted to ask you, what is your suggestion for young engineers, young builders that want to approach very, very hard industry and want to build in it? And they know there's all sorts of problems that have to do with friction, resistance, lack of talent. Their friends telling them, hey, I work at a tech startup and I make $150K a year. Why don't you just join us, etc. Like all of this stuff, but they want to build stuff that other people find boring, and they want to explore how the traditional way of doing things can be changed and the status quo can be surpassed. What's your suggestion for them? Really high level that you would give to yourself, back when you started out.
Yeah, I see. Well, the first thing I think is important is that what you want to do, you want to change the way stuff is built. If we put it that way, you're a young person, you're 24 years old, you're just out of a university, and you see there are so many things that needs to be addressed in this industry that we're in. That's great. Now, if you really want to change the industry, you have to make sure that you're part of changing that industry from the inside. So your first years that when you're working will not be any breakthrough because you're going to be so busy understanding what's going on rather than being that breakthrough force during your first years. So just be very patient with yourself because a breakthrough in the industry we're working in is not happening unless you are able to get you have to be trusted by everyone. When you stand up and say, hey guys, we're doing it this way, you need to be sure that your people on the floor, your engineers, your financial people, and your warehouse people, all of them understand that what he's saying is actually making sense. We should be doing that. Then you will win. Because there is one thing here that is super important to remember. What you're doing in modular construction is that you bring all the trades together and they work together very tightly. And it's not a loose relationship. In normal, other traditional construction, you will have a subcontract. And when the job is done, it's bye-bye subcontractor. And thank God I don't need to see you any longer, because maybe the relation wasn't so good. In modular construction, it's often much, much more long-term. So for you to succeed, you cannot be alone. You have to have the team with you. And for you to get the team with you, they have to trust you. And for them to give the trust in you, you have to show that you know your stuff. So just be patient the first years, learn as much as you can, try as many positions as the company will allow you, and gather experience. Don't be afraid to be in engineering 2 years and then spend a year on the floor if they would let you, or a year on site if they would let you. Because picking from these different phases of construction, that's going to build you as a very, very attractive person. So when you're 35, you will think that you're invincible. And then you will turn 45 and you will realize that, damn, I didn't know anything. But that's your journey, you know. That's how it goes. You always kind of humble yourselves with new exposure.
Cyclical Dunning-Kruger effect that'll hit you really, really hard. Helena, thank you so much for this. This has been super insightful. By the way, I was not joking when we met the first time. I will be driving up to Poland and see the factory that you're working in, because if you want to invite me and give me a tour, because I think it's going to be just incredible. I might even bring some of my friends and be like, hey guys, you want to see a factory where they make houses? And that's just incredible for people that have never seen anything like that, including me, which I haven't.
Of course.
Well,
you're so many welcome to all you and your friends, of course. No, it's fascinating. It's good that you bring this up, actually. We speak about this as a theoretical subject. And we experience the same thing when we have others inside the construction industry that are talking to us as well. And we always tell them, come see the factory. And it's not because we want to brag about, because in all earnest, the production I have here in Poland isn't all that automated and great when we look at the infusion of technology. But when you walk onto the factory floor and you realize how well set up and thought out the entire process is, and you see from skeleton to the final product, and the final product is actually, in our case, a hotel room. So you just open up that door and you feel like you stepped into a Hilton all of a sudden. That contrast, it does something to the head and imagination of people, where you can kind of feel that, ooh, you can do that here in this space. That's amazing. So I think if I was able to invite you and offer you to bite that would be wonderful.
I'd love that. I mean, let's set this up, and let's also set up a part 2 soon. Because I feel like this is one of the topics that I love to keep exploring and understanding about, and let the audience kind of like absorb. Because it's one that it's at the forefront of innovation in one of the sectors that I care about the most, which is construction. So, again, thanks a lot for synthesizing so many years of experience in just an hour of podcast. So thank you very much, Helena. I'll let you get to your busy day building, factories that build houses, and see you soon on BitBuilders.
Thank you so much.